Hello again, fifth graders. Are you ready for another exciting science lesson about magnets? Okay, so today we are going to do lesson 74. We're going to talk about the effect a magnet has on other substances, and we're going to talk about what an electromagnet is. Okay, so we talked about what non-contact forces are. That means it doesn't have to touch to have an effect on it. So magnets would be an example of that, or gravity is another example. And remember the poles, you have a north pole and a south pole on each magnet, and they have to be opposite to attract to each other. If they are the same, they will repel each other. Okay, so we are going to be on page 6 and talk about how the effect a magnet has on an object. So follow along as I read paragraph 4 on page 6. The effect a magnet has on an object depends on the strength and size of the magnetic field and the distance the object is from the magnet. The stronger the magnet, the larger the magnet, or the closer the magnet is to an object, the greater the effect the magnet has on the object. Neodymium magnets are very strong magnets made from an alloy of neodymium, iron, and boron. You can see the chemical symbol there too. Okay, so the effect depends on the strength and the size of the magnetic field and the distance that the object is from the magnet. So it's very similar to gravity. The bigger the object, the more gravity, bigger object, more magnetism also. So in the first sentence, highlight the words depends on the strength and size of the magnetic field and the distance the object is from the magnet. So basically from depends all the way to the end of the sentence. So I'll say it again. You're going to highlight depends on the strength and size of the magnetic field and the distance the object is from the magnet. Okay, and here is an important thing to keep in mind. It's important to keep all magnets at least 20 inches from laptop computers, pacemakers, hearing aids, and credit cards so that the magnetic field of the magnet doesn't damage these objects. Okay, so that's why a lot of times some purses will have magnets for clasps, but if you keep your credit card too close to that magnet, it's going to demagnetize the strip on the credit card, which most of them have that little computer chip nowadays, but the little strip that goes across the top is magnetized, and it can be demagnetized if you get it too close. So it'll really mess up the credit card. Okay, and pacemakers, that's another big one. And I think we'll get a little more into this, but basically if you go into an MRI machine, it's basically a gigantic magnetic field. So if you have a pacemaker, it can really damage your body. It'll pull on the pacemaker. A pacemaker is basically a device that'll keep your heart pumping at the correct rate. My grandpa has one of these. If you have a lot of heart problems, if your heart doesn't pump like it's supposed to, they'll put a pacemaker in you, and it just keeps the heart pumping at the correct rate. But if you go to an MRI machine and you have a pacemaker, that pacemaker is going to either come all the way out, depending on how strong the pull is, or it might just get shifted somewhere in your body. So that's why they always ask, do you have a pacemaker? Because that can really damage it if you get an MRI. Okay, so it says neodymium magnets are powerful magnets that are used in electric motors for cars and generators for wind turbines. Okay, and then I don't have the magnets to show you right now, but if I did, I could compare a neodymium magnet with a magnet that's not a neodymium magnet. Okay, so these magnets are different shapes. Well, I would show you like a horseshoe magnet and a bar magnet, basically is what it is. They're about the same size, but one is incredibly stronger than the other one. Okay. So we're on to paragraph 5 on page 7. And we're going to talk about what kinds of materials and objects that are strongly attracted by magnets. Because as you probably know, a lot of objects will not be that affected by magnets. If you try to stick a magnet onto a wooden table, it's not going to stay. But if you stick it onto a fridge, at least the sides of fridges, I know we have a stainless steel fridge, so we have to use the size. It will it will stick on there because of the material it's made out of. So the materials that are strongly attracted by magnets are called ferromagnetic materials. So paragraph 5, it says, magnets affect all elements and compounds, but different elements and compounds are affected to different extents. Materials and objects containing the elements iron, cobalt, and nickel are strongly attracted to a magnet and are called ferromagnetic materials. Ferromagnetic objects can be magnetized, which means turned into magnets, by exposing them to a magnetic field. So you can turn one experiment, I don't remember if we do it in this unit or not, but you can basically take a nail and you can attach it to a battery, and that's a way to make an electromagnet, which is what we're going to talk about in a minute. Okay, so you can make it magnetic. Okay, and so at the end of the second sentence, highlight the word ferromagnetic. And ferro means iron in Latin. That's why it's Fe on the periodic table, because it's ferro, Ferro. Okay, so steel, an alloy with a high percentage of iron, is a ferromagnetic material. Okay. So above the word iron, you can write the word steel if you're using your printed out copy of this booklet. Okay. And if you remember earlier in the year, we tested out paper clips to see if they were attracted to a magnet, and they are because they have iron in them. Okay. And so, like I said, a nail will also be attracted because it has iron in it. It's ferromagnetic. Okay. And then also, if you take a nail and if you stroke it against a magnet, it will make it temporarily magnetic also, which is kind of a cool thing to see. So if you have a nail at home, I would use kind of a big one instead of the little ones that'll be harder to do. If you have like a big, thick size nail, and put it against a magnet, and you can make it temporarily magnetic. And you can make it a permanent magnet basically by making it an electromagnet, which we'll get into later. Okay, so if you do that to a nail and then you put it by some paper clips, it'll lift up those paper clips. You can try that at home if you have those materials. Okay, so now we're going to talk about what paramagnetic or diamagnetic means. We're in paragraph 6. Substances that are very weakly attracted to a magnet are described as paramagnetic. Most elements and compounds are paramagnetic substances. Aluminum, tin, and platinum are examples of paramagnetic substances. Substances that are repelled by both poles of a magnet are described as diamagnetic. Diamagnetic substances include copper, gold, zinc, mercury, plastic, rubber, wood, glass, water, and air. Okay, so at the end of the first sentence, I want you to highlight paramagnetic. So they are attracted to a magnet, but it's a very weak attraction, paramagnetic. So that's like aluminum. And then at the end of the fourth sentence, I want you to highlight the word diamagnetic. So that's going to be repelled by both poles of the magnet. Okay, so it's like water and air and wood and glass, all the things that are not very magnetic materials. Basically, either very weak metals or things that are not metal. So a nickel coin is an alloy of 75% copper and 25% nickel. So if you remember, we talked about nickel is a very strongly attracted metal to a magnet. Okay, so you would think a nickel coin would be attracted to a magnet, but it's not because it's only 25% nickel that's in that nickel coin. 75% of it is copper, and copper is diamagnetic. So if you try to take a nickel and put it to a magnet, it's not going to stay because most of it is copper. Okay. Let's see, and then I can't demonstrate to you, so I'll skip that. So if you remember, steel is attracted to a magnet. Okay, so if you ever think about, if you've ever been to like a scrap metal place or like a, like a dump where they have a bunch of cars and things like that and metal materials everywhere. If you go to one of those places, they have a big electromagnet that can pick up the scrap metal and move it. So we're going to talk about how those electromagnets work. So I'm on paragraph 7. An electric current flowing through a wire produces a magnetic field around the wire. An electric current and a ferromagnetic material can be used to create an electromagnet. An electromagnet can be made by wrapping a copper wire around an iron object and running an electric current through the wire. An electromagnet is a temporary magnet. When the current is running, the ferromagnetic object around which the wire is wrapped becomes a magnet. When the current is removed, the object is no longer magnetized. Okay, so that's why sometimes those big electromagnets will pick up the steel and sometimes they won't. It has to be turned on for it to actually work, for it to be magnetized. And the same thing I said, you can make your own electromagnet by taking one of those big nails, and you can take a battery. If you have a copper wire, attach it to the battery, attach the other end to the nail. You kind of have to wrap it around it a little bit. And then if you even have one of those giant batteries that you can kind of turn the electric current on and off, that would work even better if you have some kind of system. I know a lot of you have kind of circuit sets. That would be a great way to test this out. But basically, you wrap a little wire around the iron, around the nail. If you undo it, it will not be magnetized. But if you attach that wire and it's attached to the electrical source, it will make an electromagnet. You can pick up things with that nail all over the place. So that's something you could try out at home too if you have those materials. So at the end of the second sentence, highlight the word electromagnet. So you have to have an electric current running through the wire in order to make the magnet work. Okay? And then if you go on the Nancy Larson website, and I'll give you the username and password again so you can go check it out. There's a slideshow on there for lesson 74. It's going to show you electromagnets. So you can see one of those giant ones that picks up the scrap metal like I was telling you about. Okay, and you can see what I'm talking about other than me just making the hand motions. So it makes a little more sense. All right, so that's it for that lesson. Make sure you go on and do the lesson 74 review after you're done watching and highlighting, and I will see you next time.